So, welcome to the Day Friday. My name is Michael Schimken. I'm the CEO of Scalefree. We have this session here every Friday to allow you, the audience, to ask questions about data vaults, data-driven applications, cloud computing, NLP, computing, whatever you want. I mean, in that line, right? And then you can use the chat client here if you want to raise a question live. That's fine. You can use the Q&A. You can just raise your hand. But also, I'll show you a link essentially after today's session where you can submit your questions and we pick them up in one of the following sessions. If you receive multiple questions, I will be cherry picking depending on my mood in the worst case. Typically, I try to find some line into some general topic. And if there would be no questions at all, I will talk about cluster here, my little hobby project, but I didn't do much progress thanks to you guys because you asked me a lot of questions. It's good. All right, so we received a couple of questions actually around PIT tables. And so I would dedicate the next 2 sessions at least for PIT tables. Let me just show you the first slide, or first question first. And this one is about PIT timelines. And the question here is from a user here, from a developer. Why do many examples of PIT point timetables use load date timestamps instead of applied date times from the source? Even though analysts typically want to restore data for a particular datetime as it was in the source. Are there implementations of PIT tables to combine both applied datetimes and load datetimes? Yes and no. Let's start with the easy one, or the first one that you often see. And the idea is this, structure-wise. Let's start with that on the left. The structure of a PIT table is quite simple. You have a primary key, which is in the book, we use a hash value calculated on the alternate key. Talk about that. So it's a unique identifier here for the for each record in the PIT table. The alternate key, the alternate key is the hash key of the parent. So the PIT table is attached to a hub or link, and that hash key here is the hash key of the parent. In this case, the passenger. And then you have a snapshot date. Snapshot date indicates when do you want to deliver the information to the end user, and that's typically on a regular basis. So every day at 8 o'clock in the morning, you're delivering the next snapshot date, or once per hour, once per second, whatever. So this snapshot date indicates the partition essentially of the PIT table. And then you have 2 columns per satellite. 2, not 1. 2 columns because you refer to the most recent delta that describes the passenger on this given snapshot date. And the description in the satellite is identified by 2 columns, the hash key of the delta and the primary key. The hash key and the load date, sorry. That's the primary key I wanted to say. That's the primary key of the satellite. So in order to identify the delta that should be used to describe the passenger X on a given snapshot date is identified by those 2 elements. In Data 1.0, they used only the load date time step, but that's a inefficient design. This design is much more efficient because having only the load date in the PIT table means that you have to have millions of records in your satellites per every satellite, millions of so-called ghost records. And here, it only requires 1 ghost record per satellite. You can generate this out with a create table statement, and then you're done. All right. So this is more efficient design. 2 columns per satellite. So what we see here is there's 3 satellites attached to the parent, to the passenger hub, and that's included in the PIT table section. All right. That's the idea. Now, when loading this, one more comment. As I said, the passenger key, that's a hash value calculated from the business key of the passenger, the business key behind this hash key here, and the snapshot date. That gives you a unique identifier per record in the PIT table, because this honestly is also the alternate key of the table, right? So if this is unique in combination, the resulting hash key must be unique as well. All right, that's the idea of the structure. Now, when we load the PIT table, what we do is we always select all the business keys from the hub, and then typically cross-join that with the snapshots to be loaded from a control table. So let's say we have 10 million rows in the passenger hub, 2 snapshots are indicated in the control table to be loaded. Then we would essentially join 10 million rows times 2, 20 million rows. That's what you get from this query essentially. 2 partitions to be loaded. And then here it's a bit simplified, there's no control table involved here. So we select all the business keys from the hub, and then perform the complex join operations. Remember, the PIT table's purpose is to reduce the complexity of your joins. Turn a left join with complex join condition into an inner join with equi-join condition. And so, but we have to, for that, we have to calculate the left outer join with complex join condition once, store the results in the index, in this PIT table index if you want, and then use the PIT table as an index for producing dimensions. So we do a left outer join into the satellite, and then we have the complex join condition. We're looking for the delta where the hash key matches the passenger, well, in this case, airport, sorry for that, I copied something together, where the hash key from the satellite matches the hash key in the hub. And then we're looking for the delta where the snapshot dates that we are currently loading into the table this morning, 8 o'clock, is between the load date and load end date of the delta. So here, and this comes straight from the book. So we look for this parameter here. It's a parameterized input statement. This parameter here is the snapshot date. So snapshot date between load date and load end date. Now you're saying, well, wait, we don't have a load end date anymore, right? You're right. So we don't have a load end date anymore. This comes from the book. What we do is two options. You either have a virtualized load end date in the on the satellite. What we typically do is these days we have a table for the satellite where we don't have a load end date anymore. But then we create a view on top where we calculate the load end date virtually using the lag function, and then add all the other attributes to the satellite view. And this satellite view looks exactly like the statement as, or the satellite as in the book. And that's, you could use that one for loading, or you embed the lead or lag function here in this join condition essentially, that one way or the other. All right, so this one gives me the delta, which was the most recent delta this morning at 8 o'clock in the morning, right? That's the basic idea. That's the standard PIT table, let's call it like this. And it's called the standard PIT table actually. All right. Now the question now, let me, if I go back 1 second, there's a comment here in the chat. So correct, there's a question here from Eric. So the passenger business key itself is not part of the PIT structure. That's correct. We don't have the business key in the PIT table structure, because to get the business key, what you have to do is you join essentially based on the hash key of the passenger, you join into the hub with an inner join, EP join condition, and that's how you get the business key. I would add, and I know in the training material, there is the business key involved, but only for didactical purposes. And you could add the business key to the PIT table structure. But typically we only do this when we want to partition. So we add attributes to the PIT table typically only when we want to partition by them in a traditional database. But the business key of the passenger is not a partition key either. So I would rather maybe join the, or denormalize the, or pre-join, whatever you call it. I would pre-join maybe the country of the passenger into the PIT table. So I can partition the table by the country, for example. It gives me bigger partitions essentially. So business keys I typically don't add to the PIT tables. All right, but that's the basic structure, the basic idea. And now let me just go back to the question here. So now it's all about applied timelines. So apparently in the source data set, there is some valid from valid to timeline, for example, or some subscription start end date or something, some business-driven timelines, business timelines. And we have to be aware they can change all the time, right? So they could be modified in the source system. You can modify the valid from date, valid to date, right? It's the business timeline. And now, what about combining this? Yeah, let's do this. And it's actually in the book, so it's $60 on Amazon, right? So just go for it. It's there. The thing is this: we call this a temporal PIT for multi-temporal solutions. The structure on the left is exactly the same as before. There's no change. So it has the same structure, but we modify and slightly modify the loading mechanism here. The idea is this: typically, we said we're loading a delta based on the fact that the snapshot date is between load date and load end date. That's essentially the condition to selecting the delta and activating that in the index. What we do is we can modify it or extend this essentially. Either replace that and use snapshot date between valid from and valid to, or have both. Snapshot date must be between load date and load end date, and snapshot date must be between valid from valid to. Which one you use, I don't know. With every client we talk to, they want to apply a little bit different. So it really depends. You have to ask, you have to figure out how they want to apply these descriptions to the data essentially, right? The list prices and what else. So depending on their answers, depending on what their intention is, you either go one way or the other. I'm not 100% sure. It changes from client to client to client. So, but that's the idea. We modify the loading process of the PIT table, and then what you have to do is, the dimension view on top is exactly the same as before. So instead of modifying the data in the satellites or rearranging the data in the satellites, we just rearrange the activation of the deltas in this PIT table index. I like to call it PIT table index, right? Because it's an index into your data, a index that you build by yourself. So we're rearranging deltas in the index only, in the PIT table, right? That's the only trick. And then the view just presents the list prices, backdated or post-dated, depending on what the users want, essentially. Now, the thing is, there's one caveat, or a couple of caveats, but the biggest one is this. If they modify the valid from valid to dates in the source data set, so I said they can, right? You can just update it. You have to essentially drop all the partitions based on the snapshot. So we typically partition this table by the snapshot date. You drop all the partitions where the snapshot date is older than the latest, the earliest new, or the smallest new valid from or valid to date. So this pattern here is actually great. Let's think about this pattern. And I really want to donate today's session here on this structure only. Let's think about this. What can we do with this? What we do is, with most clients and internally as well, in the book, we have two tables here. We have a standard PIT table and a T-PIT now, right? These are two independent tables in the book. Bit inflexible in my opinion. What we do is we create only one PIT table and we partition it by a type code. And the type code says PIT, T-PIT, T-PIT2, what else? Q-PIT, and so on. So we have a type code, and this type code is added to the alternate key of the table, right? And then what you can do with it is quite simple. The cool thing is you load all these different PIT tables into one table structure in a database, and then you have a filter dimension in your dashboard, so the user can switch from the standard PIT, where you only activate the deltas by the load date, load end date, visual end date, and they can switch from this standard PIT to the temporal PIT. And you can also have multiple temporal PITs now, multiple partitions. Just call it T-PIT, T-PIT2, or give it a real name, right? So give it some indicator, some identifier, and now they can switch from one timeline to the next. Just switch from timeline to timeline, essentially. And that's a cool thing. They love it because it's super fast. This is it's all indexed, right? So you prepare the indexes and so on, and it's extremely fast like this. They switch in the dashboard from timeline to timeline and just present the data differently. Now, sounds super flexible, but we don't do this anymore. This pattern is all valid. The problem is, the biggest problem with this pattern is this. I mean, there's two big problems. One problem is that you cannot really prevent, well, you can prevent. One problem is if you mess up the application timelines, you will get gaps in your application, in the timeline application, right? Well, so be it. Whatever you do, if you mess up the timeline application, you mess it up. Even in other approaches, right? So be aware that you correctly assign these the timelines here. That's one thing. The good thing is you only mess up the business wall. PIT tables are part of the business wall, right? So you can always fix this and reload the PIT tables only. You don't have to reload all the data from the sources section. So that's a good news. So that's one bummer, but we have this bummer every day in every solution that I'm promoting here. So just want to make sure you're aware of this. And then the other issue is something bigger. So I said when you modify when the users modify the valid from date in the source, you have to rebuild these partitions, right? And that's a bummer. It works for those customers where they only have a small change on the valid from or valid to dates. And by small change, I don't mean the number of records. If they only modify by a couple of days, let's say they change the valid from date of today to 3 days before, or maybe 3 days after, 5 days after, something like that. But if they modify the valid from date to a year before, you have to drop all the partitions until that date, the new, smallest, earliest valid from or valid to date. So you're dropping a year of data from the PIT table and rebuild a year of data in the PIT table. And that becomes, I mean, you have to maintain all this. And that's the problem. So depending on your customers, on your data sources, this might work or not, because the maintenance might be way too big. What we learn in the bootcamp, what we learn in the bootcamp is that we apply these timelines. If you want to build a multi-temporal solution, we apply these timelines as late as possible, right? Many people do the mistake, they apply timelines in the already in the raw data vault without realizing that multi-temporal solutions is an information delivery concern, not a concern of data warehouse. So apply it late. And then, so what we do is we don't use this PIT table, this temporal PIT table template anymore. what we do is instead we push. The idea is this: we push the timeline application all the way into the dashboard. In every project, in every context, the business user must explain to me how they want to apply these timelines. They need to explain it to me because every customer is a little bit different. They want to do something else. So they have to explain it to me. And then I'm implementing this in a TPIT, for example. But if they have to explain it to me, why don't we just deliver these timelines as descriptive attributes to the dimension, add it to the dimension view, and deliver it to the end user so they can apply it by themselves? Gives them the most flexible solution with one caveat: performance. So it might be the case that in a dashboard, they experience performance issues when they apply these timelines. So be it. In this case, what we do is we drag the application of the timelines upstream again. So instead of implementing this in the dashboard, we do it in the information map, in the dimension view. That's where we apply these timelines according to the rules they set up in the dashboard. So I'm slowly dragging this upstream, and if the dimension query, the application to temporal timelines in the dimension query wouldn't be fast enough, then the fastest solution would be the TPIT. But typically, the application of the timelines in the dimension is fast enough. So we don't, I would use a TPIT, but the maintenance is the issue, right? So I don't want to maintain all these partitions, and that's why I'm trying to avoid using it. So I'm just using a standard PIT and applying timelines in the dimension view section, as long as I can. Except if I have performance issues, then I would still use the TPIT, and you can't beat the TPIT performance-wise. All right, so that's how we do it. Those concepts we discussed briefly, only briefly, in the bootcamp training that you can check out on the website. There is a multi-temporal class where we discuss these patterns up and down. Not well booked, by the way, so typically smaller groups, but in my opinion, it's worth the money. So it's worth wasting the time, essentially. So come to the class, we discuss all these patterns up and down, and lots of tricks, essentially, how we can apply these timelines. Very simple tricks, very easy ones. Go for it. All right, couple of comments here. I don't get the first one, usually not, but if you have real-time services, as it can speed up the service, you may do anything in business vault. For example, business key PIT table. Yeah, so there's nothing against having any descriptive attributes in the PIT table. And if you, let's say, take advantage performance-wise, or maybe in the application of business logic, make it easier to apply business logic, go for it. Add the business keys to the PIT table. So you can modify the structures of PIT and bridge tables. I wouldn't always let you know, but you can do a lot more in the business vault than you can do in the raw data vault. In the raw data, it's all about making sure you can reconstruct your original delivery, you don't lose data, and so on. But in business vault, you have much more freedom. I would stick to the standard templates, to the standard patterns, especially for the business hubs, links, and satellites in the business vault. But for the PIT tables, we do a lot of performance tuning. Yes, absolutely. But here's another one. This is a good question. I'm not answering this today. What about real-time services and PIT tables? Because I said we're loading a daily snapshot into the PIT table. Fully agree, it works. And we could also load an hourly snapshot into the PIT table. But what about real-time systems? When you have changes coming in for your customers or for whatever, every second. So you could theoretically add a partition every second into the PIT table in a relational database, right? But that's, nobody can tell me, not even myself, can tell here, make the statement that this will work, right, on real-time systems, on realistic data volume. So you can't maintain a PIT table in a relational database. But it's another question, essentially. So I keep it up to you, give you some ideas to ask in the form. Another question is it possible to use distinct load date values from all satellites to build snapshot date? Yeah, it's a common question here. So typically the snapshot date is defined on a regular basis. Every day at 8 o'clock, you essentially deliver the information to the end user, and then it remains stable for a while until it gets replaced by the next snapshot date, the next delivery. So typically on a daily level or once per hour and so on. And often users would like to have essentially because they want to produce a type 2 dimension where you capture every change in your dimension, right? So they want to collect all the load dates from the raw data vault and load them as snapshot dates in the PIT table. Yes, theoretically you can do that, but somebody has to pay for the storage, right? And I wouldn't do it. I would rather, we have typically other tricks that we use for dealing with those requests. I would rather, focus on a daily or focus on a regular snapshot date. And then what we do is, first of all, you have to distinguish here two cases. There's two types of queries against the data vault or data warehouse in general. One is that they want to aggregate data. They want to see, let's say, the revenue per customers on a certain time stamp. Well, that's a query against the snapshot data, right? That's typically sufficient. I don't need to know how the revenue changed within this, and I could even find it out, to be honest, without this concern. So I could even tell you how the revenue evolved over the day. I have all this data essentially without being limited by or without requiring to having all the load dates as snapshot dates in the PIT table. The other type of query is often that users would like to see all the changes to a certain customer or taxpayer and so on. But it's a different query. And I would not use a PIT table for this purpose, to be honest, because the PIT table is really optimized for producing dimensions in aggregated queries. While if I would need all changes, the better query would be to select the data from the satellite for one particular customer, right? So I'm just starting with the satellite, getting all the data from there and presenting it essentially, roughly. So that is a different query pattern. And I'm not aggregating across all customers. I'm showing only one particular customer essentially, right? That's the basic idea. So different query patterns, and that's why I don't need this pattern typically. To have all the load dates as snapshot dates in the PIT table, and none of our customers will pay for storage. That's what I can tell you. All right, good. I have more questions coming up for the PIT table from the same person who asked this question here essentially. But if you have more questions, let's have essentially a series of PIT table questions. Why not? All right. So I hope you enjoyed it. If you have questions, for example, how does PIT table work in real time? Just saying, use this formula sfr.e/Friday. That's where you can submit your questions essentially and upload pictures if you want, diagrams, team pictures. I would show them. And yeah, so let's use this form essentially. I show them depending on what the picture shows. And then also check out our other webinars at Scalefree. At scalefree.to/webinars, you'll find 2 more webinars, one for Warescape and one for DBT. They are on a monthly basis, not on a weekly basis, but also worth to watch. And if you can't wait for next week, then use the Data World Innovators Community, DVIC, a free forum essentially, where you can also submit questions, and people from Ignition Data in Australia and from Scalefree in Europe, they will essentially answer questions as fast as they can. And we also answer questions in a live stream once in a while, roughly once a month. Yeah, where we also pick up some questions from the forum sometimes, from the audience. Yeah, also good format. All right, and it's free, right? So free stuff. Okay, cool. Thanks for joining, guys. Enjoy your free weekend, and hope to see you next Friday again, where we pick up the PIT table topic again. Good. Thank you, guys.